Hello, my name is Ben Holmgren. I'm an undergrad at Montana State University, and I'm going to talk about a little bit of work I've been doing on discrete Morse theory, which is a subfield of computational topology. And it's really exciting because it's useful in all kinds of wide applications in data science. And for more of a conversation on that, I definitely invite you to come to my poster session. I'd love to share some of the exciting things that discrete Morse theory can be used for. But for a brief overview of what it even is and what we've been working on, discrete Morse theory is inspired from classical Morse theory, which uses functions on smooth manifolds. And specifically, it uses the critical points of those functions, which really end up telling us quite a lot about the topology of that manifold. It turns out that we can use similar techniques on data. And for our purposes, we're really concentrating on data in the form of a simplicial complex, which we can just easily think of as arbitrarily high dimensional generalizations of triangles connected together. And we can interpret discrete Morse theory and discrete Morse functions in three different ways. Specifically for us, combinatorially, examining discrete Morse functions ends up being really helpful in decreasing the time complexity needed to actually generate these discrete Morse functions on a simplicial complex. Arbitrarily generating a discrete Morse function is an NP-hard problem if we don't have any help and if the discrete Morse function is the best possible one with the minimal number of critical cells. And we show that we can make a pretty good discrete Morse function in nearly linear time, actually. And we use a little bit of help. We have function values given beforehand on the vertices of a simplicial complex. But in the end, we can create a discrete Morse function that's okay in time proportional to the dimension of that simplicial complex multiplied by the total number of simplices. This is an exciting result, and it's really paved the way for a lot of new applications in Morse theory and the viability of Morse theory as a really practical field going forward. And for an idea of some future work that's going on now, now we'd like to make our discrete Morse functions even better, even more indicative of the topology of a simplicial complex. I'd love to share more if you'd visit my poster session about some more of the work we've been doing and why these new problems are perhaps just as exciting, if not even more exciting than what we've already done. So I hope you'll stop by my poster session. Thank you so much for watching.